Welcome, Professor Bright here, and we are going to talk about related rates today. But before we get there, we have some announcements and a warm-up idea for you to think about. So first, some announcements. Exam 2, this is all old information. There is not going to be a differentiation gateway. So next Thursday, you will have Exam 2, and you will have a full 2 hours to work on it. Okay, what's going to happen, and we'll talk about this again in class and at the review session next week, is that at 3:55 on next Tuesday, so that's 11/19, you will have the exam released, and it is going to be due in Gradescope at 6:00 p.m. Okay, and if it is coming in after 6 o'clock, no matter if there are tech issues or whatnot, it is late. So make sure to get that in by 6 p.m. Begin the scanning process early because some of you have found out it takes a while to scan and upload, and Gradescope can, have its moments too. So don't worry about the gateway, but we still have the exam 2 going on next Thursday. Other than that, I'll just mention that exam 2, it's over the end of chapter 2, all of chapter 3, and I shouldn't say there's no calculators, but there are still the open resources. If you're using resources, you're going to run out of time. All right, so that's our announcements. First thing after that is we want to think about this question. So we might have a rectangle, and we can imagine that its length and width are increasing over time. So we have this rectangle, and we have its length and its width, and we have some relations there, but we're curious about how the area changes over time. So this has a certain area. What happens to that area as we increase time? Because that's really how we're thinking of calculus, that we're thinking about change in quantities. We know that area is certainly length times width from geometry, and now we just have to think about this change. So just to model this, I open this in Desmos, and I have some things set up here. So I have the width and length, which are actually functions of time because they are changing over time. And then we have L, and then all I did here was calculate the area at specific moments in time. So you can see that as I change area, and maybe let me just shift this up here, all this horizontal line is just telling you the value of area, but you can notice that it changes kind of quickly, and you can see that by this value here, but it starts to change quickly as we increase A. Okay, but can we describe how quickly this area is changing? And that's kind of our focus for our study in related rates, is that we are thinking of a scenario. We want to say, okay, here's the equation, but we're acknowledging that in that equation, the quantities are changing according to time. So if we can model that behavior and recognize, yeah, these are quantities, but they're changing in time, we can represent that change as a derivative, right? A derivative is a change in a variable with respect to another. Here, we're going to take, say, the change in width with respect to time. So that's a derivative. It's a time derivative, d dt. Okay, and we'll apply that to L as well. So we won't solve this specific problem, but that's the general premise of today, as we acknowledge, yes, area is length times width, but length and width are each changing over time, and then we can solve that going forward to find, or we can use that going forward to find the change in area. So let's dig into some questions where we can solve things fully.